Coding agent solved the LRU cache LeetCode problem in 3 seconds. Clean code, correct pointers, big O analysis included. So what exactly is your job now? Here is what a coding agent did not do. Look at WhatsApp's home screen and say we must use a doubly linked list with a hash map for eviction. Because if Redis evicts the wrong chat session to save memory, 2 billion users will see a stale unread count. That decision made before any code is written is the one that guarantees a 99% cache hit rate for recent chats. After this video, you will be able to make it in the next 10 minutes. You will learn the judgment call, not just the algorithm. That makes you the one engineer who picks the right structure before anyone writes a prompt. 5 things you will own after this video. Why naive caching policies serve stale data. The core concept of combining a doubly linked list with a hash map, the exact WhatsApp production constraint of a 99% hit rate for recent chats, the stale count trap, and the survival skill, the exact judgment call AI misses. If you watch this video to the end, you will be able to answer an interview question better than 99% of candidates who just grind it. Let us start with what breaks. Imagine a user opens WhatsApp. The home screen immediately requests the latest unread message counts for their active chats. The API gateway asks the memory cache, but because the cache was full, it used a naive random eviction policy. It deleted an active group chat from memory to make room for an old archived chat. The cache returns a miss. The system is forced to query the massive Cassandra database. This takes 50 milliseconds instead of 1 millisecond. The user stares at a blank screen or a stale unread count, while the database churns at 2 billion users opening the app 20 times a day. This cache miss rate destroys the database. The naive approach breaks the product because it optimizes for memory space instead of eviction accuracy. This constraint forces the least recently used cache. Finding the oldest item to delete in a massive array is like searching a crowded room for the person who arrived first. It takes time. A least recently used cache combined with a doubly linked list is like a physical line. The moment you talk to someone, they move to the front of the line. The person at the very back is always the oldest. No searching, you just chop off the back of the line. Here is how it works under the hood. You combine two data structures. A hash map provides OV1 lookup to find any chat instantly. But hash maps are unordered, so every value in the map is actually a node in a doubly linked list. When a chat gets a new message, you find it instantly with the hash map. Sever its current links in OV1 time and move it to the head of the list. The tail of the list is always the oldest chat. When memory is full, you just delete the tail. Every data structure trades one thing for another. A doubly linked list is complex. You have to carefully manage next and previous pointers. If you drop a pointer during an update, you create a memory leak or a fatal crash. It also consumes extra memory just to store those directions. But at WhatsApp scale, complex code is a trivial price to pay. You gladly trade engineering complexity and extra memory overhead to guarantee that one eviction speed. Let us look at how WhatsApp applies this in production. The WhatsApp architecture explicitly optimizes for cache hit rates. Let us trace how the LRU cache ensures your active group chats never get evicted when you receive a message. Bob receives a new message in his family group chat. The WebSocket server updates the unread count in the Redis cache. It uses the hash map to find the family node in exactly 01 time. Because this chat is now active, Redis updates the doubly linked list pointers. It detaches the family node from the middle of the list and wires it directly to the head pointer. The Redis instance hits its maximum memory capacity. It needs to evict a chat session. It doesn't scan or search, it simply looks at the tail pointer of the doubly linked list. It sees a chat from 3 years ago that hasn't been opened. It deletes the tail node in O1 time. When Bob opens the app, the API asks for the family chat because it is at the head of the list. It is a guaranteed cache hit. The home screen renders the unread badge instantly. If this kind of judgment call mapping pointer manipulation to a specific UI constraint is what you want to make confidently. Subscribe now every Saturday. One DSA judgment call free. If your requirement is a 99% cache hit rate, random eviction completely fails. It evicts active group chats just as often as dead ones, causing massive database load spikes. An LRU cache succeeds because it mathematically protects the chats users are actively looking at. Both approaches can evict data in O1 time, but the random cache achieves it by sacrificing accuracy. The LRU cache achieves it by paying the engineering tax of managing doubly linked list pointers. Ask an AI to build an LRU cache, and it will write the class perfectly. It is logically correct in a latent window, but it doesn't know why it matters in production. The engineer defaults to the constraint. The answer is not write the pointers. The answer is the constraint of rendering the home screen accurately for 2 billion users requires an eviction policy that maps to human behavior. Therefore, we must use an LRU doubly linked list. That answer is the one that gets you hired. Before this video, you knew an LRU cache was a doubly linked list combined with a hash map. After this video, you know that LRU cache is the eviction policy that keeps WhatsApp's home screen recent chats accurate without requerying Cassandra on every single screen tap. Cache eviction is not a data structure exercise. It is the decision that determines whether 2 billion users see the right unread count. That distinction is your survival skill. Next Saturday, stacks and queues. If a user is offline for 7 days, their messages stack up on the server. If you use a LIFO stack to deliver them, they read the newest message first, completely ruining the conversation context. We will design the offline message queue that guarantees strict FIFO ordering. Subscribe to ByteLearn for the complete one engineer system WhatsApp DSA edition. One data structure, one real world constraint every Saturday. Hit the bell. See you Saturday. Question: which DSA concept surprised you most? Drop it below. I reply to the first 10.